So this is review session number 2. It'll be up on my YouTube channel once we're done. For you to peruse at your leisure. For now, Cecilia, go ahead. What's the question?
You mentioned that it's if we're good if we study the review. Is that the one we went over yesterday?
Yes.
With the bunch of multiple choice?
Yes, we didn't quite finish the whole thing, but yes, that is the one we went over yesterday.
Okay, thank you.
You're welcome. So if you have questions, now's the time to ask. Go ahead, Alexis. Alexis, I didn't see you here. Go ahead.
Sorry, Professor, I'm from another class. We were referred to you just to pop in. Sorry about that.
Okay.
I was just wondering if the first review session, the one you hosted yesterday, was on YouTube as well?
Yeah, my first one is up. Let me figure out let me get the link to it and give me a second. So I'm on a hotspot right now, so my internet is a little shaky, but I'll try to find the link and get it up. Unless I know Rachel, I saw that you were on my channel yesterday. If you have the link, would you mind putting it in the chat? If not, I'll wait for it. But one way or the other, we'll get it up there somehow. Meanwhile, are there any questions that you'd like me to go over today?
The review you're talking about is the one that's on Canvas, right? On the files.
I think so. I wasn't the one who actually uploaded it. One of the people in the room yesterday shared it, and that's the one that we worked on for the tutoring lab. Oh, that's my channel, Mandel. Thank you. Yeah, I believe it's in the tutoring lab. I think so. And we went through like 100 questions yesterday. I think it was like 112 questions somebody said, and we covered like 100 of them.
Those are the ones from the Canvas tutoring.
I believe so, yeah.
And those are the ones you're referring to that are similar to the final, right?
You didn't hear it from me.
Do you want me to share my screen?
Yeah, if you have a question, sure, go ahead.
Okay. Oh, it says host disabled.
Oh, give me a second, sorry. Okay, go ahead.
Okay. I had a question on the first packet. I'm not sure if we went over it yesterday. It's
this one, well, even if we did, we didn't get this far, I'll tell you that much.
Okay.
So 103, that's your question?
Yeah.
All right, let's take a look, see. So smokers don't live as long on the average as non-smokers, and heavy smokers don't live as long as light smokers. You regress the age at death of a group of male smokers, the number of packs per day they smoke. So apparently the more packs a day that you smoke, the lower your age when you die. So I expect a negative correlation. And therefore the slope will be less than 0.
Okay.
Well,
yeah, I had this other one. Number 27.
the Z value for a 97.8 confidence interval estimation from you is.
I didn't know how you do that on the calculator.
Well, I can show it to you on the calculator. So the first thing you're going to want to hit is the second button, followed by vars, which in blue is DISTR. Do you see it?
Yeah.
Okay. And then you're going to go down to the third one, which is inverse norm.
Okay.
Now, on your inverse norm, do you have the option of left, center, right, or do you not have that option?
No, I don't.
Okay. So then for your calculator, it only allows you to calculate to the left, but it wants a confidence interval, which is the center. So if I have 97.8% in my confidence interval, how much will that be outside of my confidence interval?
Okay.
What percent will be outside?
So 2.2.
2.2%, which means 1.1% on each side, correct?
Yeah.
Okay. So if you go to the right side of your confidence interval,
Mhm.
and you look at what's to the left of it. Let's see if I can annotate here, make it a little easier to see. So here, if I think of a normal curve, I want 97.8% to be in the middle,
Mhm.
correct?
Yeah.
Here's 97.8%. And we just figured out that this part over here is 1.1%. And therefore, this point right here to the left of it will be 98.9%. Do you agree?
Yeah.
Your calculator could only do to the left. So you're going to put in an area of 0.989. And you're going to calculate it. And what does it give you?
It says error. I put inverse norm and then I put 98.9.
No, not 98.9, 0.989, because you need a number less than 1. You need an area.
Okay, I get 2.29.
And that's your answer.
Thank you. And then, sorry, I had a last one.
Sure.
Number 45.
If a hypothesis is rejected at the 0.025 level of significance, that means the p-value is less than 0.025, correct?
Yeah.
Well, the p-value then is also less than 0.1.
That's where I was confused. Like, I see 0.025 as a percentage, so I put 2.5,
Okay.
and then the 0.1.
So
'Cause
that's not point, that's when they say 0.1, what they really mean is 0.1%. So 0.1, just like they said 0.025.
Mhm.
Actually, 1 second, hold on a second. Wait 1 second. 1 second, maybe I read it wrong. No, I didn't read it wrong. I'm sorry, I read it correct. Right, so 0.1 is 10%, correct?
Yeah.
Well, if the p-value is less than 2.5%, it's certainly less than 10%,
Oh, yeah, I see.
right?
Mhm.
And we know if the p-value is less than the level of significance, we're going to reject the null hypothesis. So if I rejected 0.025, I'm certainly going to reject it 0.1.
Yeah, so I could see it as 2.5%, below 2.5, and below 10%.
Right, exactly.
Okay, thank you so much.
You're welcome so little. All right, what else we got? Oh, Roni's here too. Roni, welcome. Welcome. I'm supposed to take attendance. Okay. Anyone? Oh, Hannah. Nice to see you, Hannah. What's up, girl?
I'm good.
Okay, so, oh, and we had Joseph Ailment here. Yeah, we got more people coming than my actual class. All right, and Edward, something or other. Edward. Okay, what else we got, guys? This is your time. This is when you get to ask questions. If you don't, what we can do is go through one of those exams like we did last time. Start maybe from the end and work our way forward, since last time we went from the forward and worked our way back.
Could we do that if that's all right with you?
Yeah, if you want to share with me, whoever it was, I forget, I'm sorry, I don't remember who was just asking, but if you want to share that, we can go to the end and work our way back. Meet in the middle.
Yeah, I'll pull it up right now.
Okay. Good afternoon, Alexis. How are you? All right, so let's go to the ends. And we will work our way back. So are we starting here or are we, Alexis, you have a question? Go ahead.
Sorry, Professor. Professor Button didn't let us know. He wasn't sure if calculating standard deviation and correlation would be on the final. Do you know if we should study that on our own time?
Are you in 140 science or 140 business?
140 science.
So I can tell you that, what can I say without giving anything away? Don't expect any heavy duty calculations to be required.
Got it. Thank you.
Okay. All right, so are we starting here or are we starting at the ends?
This is
Right.
the end.
Question 70 is the end?
Yes, for test 2.
Oh, so you know what? Let's start from the beginning then, because we didn't do this test yesterday. We were doing a different one yesterday.
Oh, I can pull up the first one and then we can.
Well, yeah, let's finish the first one first if you haven't.
What problem were we at last time? About or page?
We got to like 100, I think 98. I know we certainly got to, I know we certainly just finished this section. I don't think, so wait, scroll back up a little bit. It's like 95 or so. Let's just start, go up a little bit more. Let's start here at 95. I think it's what we got up to. All right, so questions 95 to 96 refer to the following. A store manager ran an experiment in which he varied the price of his most popular TV set brand from month to month. He recorded X equals price of TV set and Y equals number of TV sets sold each month. The correlation coefficient between the number of TV sets sold and the price of the TV set is negative 0.977. Which makes sense that it should be negative, of course. The more it costs, the fewer he's going to sell. Assume the sample variance of X is 4 and the sample, assume the sample variance of X is 4. And I guess he means the sample variance of Y is 1, because otherwise the question doesn't really make any sense. So the proportion of the total variation in the number of TV sets sold, which can be attributed to the regression on the price of the TV set, is what? So we're given the correlation coefficient, correct? Negative 0.977. We're given the sample variance of X, we're given the sample variance of Y. The question is, how can I go from those three numbers, which are the only numbers that I have, to determine the proportion of the total variation in the number of TV sets sold, which can be attributed to the regression on the price? What quantity gives me exactly that? So the answer is R squared. The square of the correlation coefficient, R squared, tells you what percent of the reason why the Y values vary can be explained by the fact that the X values are varying. So we're going to take that negative 0.977 and we're going to square it. And when I square it, not only does negative go away, but what is 0.977 squared? Anyone?
Would it
Is
be
it-
A?
Yeah.
It is 0.954, and therefore the answer is A. Does that make sense?
Yes, I actually had thought of that equation, but when I put in the calculator, I forgot to put the decimal. So that's why I got the big number.
No problem. Those stupid decimals, they're so small, but yet they do so much. All right, 96. Recall the relationship between the slope B of the line, Y equals A plus BX, and the correlation coefficient R is that. Then what is the slope? Well, they didn't give you SY and SX, not exactly at least. Although they did give you R, which is nice. So the question is, from knowing R and what they gave me, can I figure out SY and SX and therefore calculate B? And the answer better be yes, otherwise this question couldn't be there. How do I go from the sample variance of X and the sample variance of Y to calculate S sub Y and S sub X?
Do we get it from the variance?
What do I do to the variance to get it? And if you know the answer, you can just go right ahead and say, you don't have to raise your hand unless you have a question. Just, first come, first serve. So how do I take the variance? So 0.954 times 1/4. Well, 4 is not SX. 4 is the sample variance. And we want SX, which is the sample standard deviation of X. What do I do to the sample variance to get the standard deviation? You don't square it, you actually square root it. Yeah, if you square root the variance, you get the sample standard deviation. So in our case, if I take R, which is negative 0.977, and I multiply it by SY. Can you do me a favor, please scroll back up to make sure I have my SY and my SX correct? Yeah, so it should be negative 0.977 divided by 2, because times 1/2, but that's not one of the answers there. So I can only imagine there is a mistake somewhere in the problem, because
I can, I don't want to interrupt, but I have our Professor Button, he sent out like the revised version of these. Do you prefer, can I, yeah.
yeah, so if you have the revised version, that'll be better than this one, because this one doesn't make sense.
Let me just stop sharing and then go to my email and pull it up really quickly.
Okay. So this is the revised version.
Yes, this is one that he provided.
Well, this is no better.
Wouldn't it be negative 1.954?
Well, if you take negative 1.977 and multiply it by 1/2, you should get a smaller number, not a bigger number.
The answer key has it as A. What I did was the R and then times, I switched the variance to standard deviation, so I did 2/1.
Right, but SY is 1 and SX is 2, so 1's on top and 2's on bottom.
Oh, I see.
It's okay. It's just it's a bad. There's something wrong with the question, but the idea is still fine. You take your R, you take your SY, which is the square root of the sample variance. You divide it by SX, which is the square root of the sample variance for X, and you get whatever number you get. The fact that the answer is not there doesn't really mean much, as long as you understand how to get the answer when it counts. So are there questions on the approach for a problem like that?
I was gonna ask, for when you square root, you have to square root the 4 and the 1?
Yeah, but the square root of 1 is just 1, so that
Yeah.
doesn't change anything.
Oh, okay.
All
Thank
right,
you.
no problem. Number 97. In simple linear regression, suppose that the independent variable is measured in feet and the dependent variable is measured in cents. Then the y-intercept of the least squares line is measured in what? What would the y-intercept be measured in this scenario?
Would it be cents?
It would just be cents. And the y-intercept would be measured in whatever the y variable is. The y variable is in cents, so the answer is cents. All right, 98. The strength of the linear relationship between two quantitative variables can be measured by A, the slope, B, the coefficient of correlation, C, the sample mean, or D, the y-intercept. How do we measure the strength of the relationship? Yeah, that should be B immediately. The coefficient of correlation or the correlation coefficient is this, that's what it is. 99. The y-intercept in a linear regression equation represents A, the level of y when x equals 0, B, the amount of change in x per unit change in y, or vice versa. And can you scroll up, please, so I can see the bottom, if you don't mind? D, thank you, the percentage of the variation y explained by the variation in x. So A, B, C, or D. So Cynthia on the ball again. Oh, sorry, it is not C. C would be the slope of the linear regression equation. The slope tells you how steep it is, which is how much y changes as x changes. Whereas the y-intercept is just what you get when x equals 0. It's on the y-axis when x is equal to 0. Does that make sense? Okay, 100. In regression analysis, a residual is the difference between, and then we have 4 options, A, B, C, or D. Oh, Edward's jumping in. He's like, I'm not going to let Cynthia get all the credit. So a residual is the difference between the observed value and the predicted value. If you have your best fit line for whatever your data is, your points are going to be all over the place if it's a scatter plot. And then the residual is just the difference between the y value that you actually got and the y value that the line says this is where it should be if my model is correct. So the residual is a definition. It's the difference between the observed value and the predicted value. Bellin, you said B, the coefficient of correlation and the determination. That is R and R squared. Wait, see, you change your value, you change your mind, Cynthia? You went from the right answer to the wrong answer? What's happening here?
Oh, I got confused because it says of y, isn't it y?
Oh, yes. Sorry, I didn't see that either. My bad. It is C. I apologize. I just saw observed and predicted, and I didn't even realize that it said observed and predicted values of X, but it's not the observed and predicted values of X. It is the observed and predicted values of Y. Those are the variable, it's the Y. I mean, obviously my picture said that, but I didn't even read it closely, which should be a lesson to you all. Read the question, read the answers, because sometimes a slight change can make an answer wrong. Does that make sense? Any questions so far? All right, let's scroll down, please. All right, let me clear what I have here. 101. If the coefficient of correlation is 0.4, then the percentage of unexplained variation in the dependent variable is what? A, B, C, or D? Let me do it in my head first. Boom, got it. Okay, so A, B, C, or D, what is the percentage of unexplained variation in the dependent variable? Nobody. I stumped Cynthia. Didn't think today it was ever gonna happen. Edward, what do you got? Edward's got no idea. And Alexis said B. And I'm afraid that is not correct, Alexis. I feel horrible to let the wind out of your sails, but unfortunately it is not correct. Cecilia says A. Bellin says A. That's better. Educated guess let me down. The answer is C. The answer is C. This one is a two-step problem. First, they give me R. What is R? R is 0.4, correct? You can't argue with this one. They gave it to me. The coefficient of correlation is 0.4. Wait, can you scroll? Yeah, thank you. The coefficient of correlation is 0.4. Now, remember, if I take the correlation coefficient and I square it, if I take R, if I take 0.4 and I square it, what do I get? What is 0.4 squared? 0.16. But remember what this represents. This is representing how much of the variation in Y is explained by the variation in X. So if I want the percentage of unexplained variation, if 16% is explained, then how much is not explained? 84%, which is why the answer would be C.
Wait, how'd you get that? The 84
What
after
is the-
this.
What's 100 minus 16?
Oh, okay.
Right, if 16% explained, the remaining 84%, because remember, it's got to add to 100%. So the remaining
Mhm.
84% is not explained, correct?
Yeah, I see. The answer key had this one wrong.
There are quite a few mistakes. Did it say A on the answer key?
Yeah, I did.
Okay, I can understand why it would say A, because maybe the person who's writing the answer key didn't see those two letters un and unexplained. If you take out those two letters, the answer is 16%. So it's a fair mistake, but nevertheless, the explained variation is 16%. The unexplained variation will be 84%. 102. A sample of households in a certain community is selected at random from the telephone directory for a survey. 4% of the households have no telephone, 10% have only cell phones, and another 28% have unlisted telephone numbers. It is certain that the sample will suffer from, and you have four options. A, B, C, or D. So let's go out there. Mando says B. What else do we got? Bellin says D. Cynthia says B. We got 2-1. Anyone else want to throw their hat into the ring? You'll only know if you're learning if you give it a shot. So the answer is B. It is under coverage. See, a systematic bias is when you expect a certain answer because of the way the question is phrased, or perhaps the kind of people that you're asking. It's like me going to a basketball game and asking everyone, hey, what's your favorite sport? There's a bias in that direction. The issue here is that it's not possible to reach everyone. I can't reach the people with no telephone. I can't reach the people who only have cell phones, and I can't reach the people who don't have listed telephone numbers. So 42% of the population I can't get to. If I can't get to them, how can I get a response that is representative of the entire population? Answer, you can't. So the answer is A, B, under coverage. Hopefully that makes sense. 103. Smokers don't live as long on the, oh, you did this one before. Right? This one is less than 0 because the more packs you smoke, the lower the age of death, which gives you a decreasing function, which will then have a slope less than 0. And therefore the answer is B, will be less than 0. 104. For a data set, the regression equation is y hat equals 21 minus 3x. And the correlation coefficient for this data, and the answer is either A, B, C, or D. So we got a couple B's and an A. So the answer is B. Remember the formula that we had a few minutes ago, slope equals R SY over SX. Well, SY and SX are both positive. So B and R have to have the same sign. The slope here is -3. If the slope is -3, the correlation coefficient must also be negative. Correlation must be negative or else it won't work. Well, the correlation is negative when the slope is negative. They always go hand in hand. If the slope is negative, the correlation is negative. If the slope is positive, the correlation is positive. You don't have one without the other. Does that make sense? Okay. Okay, questions 105, 106 refer to the following. It is claimed that the percentage of apples attacked by cuttling moths is greater on trees bearing a small crop of apples. Interesting. A sample of 12 trees gave the scatter plot below, where X is the size of the crop in hundreds of fruits and Y is the percentage of wormy fruits. Lots of squirrels. Comment on the nature of the relationship between X and Y. We have a line. So we have A, B, C, and D. Well, hopefully you'll all eliminate 2 of those immediately. So yeah, it's a negative linear relationship. Certainly it's negative. And the only difference between B and C is whether it's nonlinear or linear. And remember, linear does not mean falls on a line, but rather it has the overall shape of a line, and this one certainly does. So, so the answer is C, negative linear relationship. All right, let's go ahead to 106. Do you all mind scrolling down just a little bit? Thank you so much. It is claimed that the percentage of apples attacked by cuttling moths is greater on tree. Okay, we just read this. Bearing a small crop of apples, a sample of children. Okay. Computations show that the least square regression equation for predicting the percentage of fruits on the size of the crop was found to be y hat equals 68.3 minus 0.8x. Now, one tree in the sample had, 1 second. I just saw Bell when you say weak relationship. I don't know if that's weak. That seems fairly moderate to strong to me. Those points really kind of cluster around the line somewhat. I mean, they're not falling on it, but I would say moderate at the worst, based upon the size of the scale that I have there. Do you agree? Does that make sense? I mean, a weak relationship should be one where you look at it and you might have to struggle for a second. Yeah, not when they're not close to the line, but yes and no. What I would say is this. If you look at the scatter plot and it takes you a second to decide what the best fit line should be, or at least in the vicinity, it's going to be weak to non-existent at all. Yeah, they're a lot more scattered apart, but they still show a best fit line. I mean, these ones here, when I look at this graph, and you said, here's a pen, draw the line, boom, without any hesitation, I'm drawing a line that's close to the line that they have there. If you can do that without any hesitation, without thinking like, oh, what's it going to be? Is it here? Is it there? Then it's not going to be weak, moderate at the worst. If you do hesitate, or you're looking at it, you're like, I don't even see a line. Now we're talking weak. Anyway, back to our question here. Computations show that the least square regression equation for predicting the percentage of lumber fruits on the side of the crop was y hat equals 68.3 minus 0.8x. One tree in the sample had 1,200 apples. Remember, the units of X are hundreds of fruits. So if it had 1,200 apples, what will be the value of X that I use for that data point? Because this is important. If it's 1,200 fruits, but the units are hundreds of fruits, hundreds of apples, whatever, then what's, then what value of X would I use for my data point there?
Do you just use 12?
You would use 12, exactly. So one tree in the sample had 12 as a value of X, we'll say, and 61% of them were wormy. Find the residual for this tree. Cynthia, I didn't even finish asking the question yet. It's like the Price is Right. I think you get ejected for answering too quick, or maybe that's Wheel of Fortune or something. I don't know. So let's go ahead and figure it out. I got to do it on my calculator. I'm not the smartest. Okay, and so how come we only use 12? Because what are the units of X? What are the units of X? If you read the question, it says the units of X are hundreds of fruit. So every unit is 100. So 1,200 apples is 12 units on the X-axis. 1,200 fruit. Does that make sense? All right. We got a couple answers of B. In fact, not only do we have an answer of B, we have a yes, it's B. Oh, that makes it 3. 3 people said B. Normally, I would say you're all correct, but unfortunately, you're not. The answer is, in fact, D. D as in not B. So the question is why? Why should it not be 58.7? I mean, hell, if you plug in 12 into your calculator and you do 68.3 minus 0.8 times 12, you do in fact get 58.7. But that's not what they're asking for. They're not asking for the value when X is 12. They're asking for the residual when X is 12. How do I find the residual when X is 12? Observe. Sorry, go ahead, speak, yes.
I solved for y hat, so I just put in the 12 and then I did 61 minus whatever I got for the y hat.
That's exactly it. The value from y hat is your predicted. It's what Cynthia, it's not predicated, it's predicted, but normally I would ignore that, but those are two different things. But the value that you get from y hat, that is your predicted. That is what the line says. This is what you should get. But 61 was what I actually got. So if I actually got 61, but the line's claiming I should get 58.7, then to find the residual, I just do 61 minus 58.7, which gives me 2.3%. Does that make sense? Yes, no, maybe so. Okay, let's do the next one. 107. The entity, person or object, that receives a given treatment is called A, B, C, or D. Melissa was so confident, she even wrote it out. But yes, the answer is C. It is an experimental unit. The person getting the treatment is not called the treatment. The treatment is what you are doing. Oh, I will treat you. I'm like a doctor. I will treat you. But you're not the treatment. You're just the thing that I'm treating. The factor is not right. The factors are the different things you change so that people get different treatments. I will expose them to this much radiation, this much radiation, or I'll give them this and I'll give them that. The response is the outcome. Well, let's see what happens. But the experimental unit, that is the individual that is receiving the treatment. Does that make sense? I hope so. 108, the sample design is the A, B, C, or D. And if you're not participating, we got so many of you here right now. You're here for your own edification and education. So go ahead and participate, type, talk, give a thumbs up. The more you participate, the more you'll get out of this and the better you will do on the test. And at the end of the day, isn't that the goal? So we gotta see my pep talk worked there. I have people A or B. Alexa, unfortunately, the rules of the game do not allow for two different answers. Although ironically, when I was proofreading the test today, I did find a couple mistakes where two different answers were correct. So he had to go and fix them. But in general, no, we need one. So Alexis, you got to pick one, A or B. B, she picked B. How many questions? Not too many. That's all I'm going to say. So 108, the sample design is the method for collecting the sample data. B is correct. Ding, ding, ding. Alexis got it right. We're so excited. We should have a party, a big parade and everything. It'll be wonderful. So yes, the answer is B. The method. Yeah, that's what I'm talking about. I want that kind of party. I am there, baby. Anyways, 109. A fruit grower. Party time, no final. Well, if you were in my class, maybe, but unfortunately you chose the other guy. And because of that, I have no sympathy for you whatsoever. Like zero. So our class is a party. That's right. 109. I haven't even read the question, Aaliyah. Oh, when did you show up, Aaliyah? That's a new person. Yeah. You know, I don't have to trust you. I know. All right, 109. A fruit grower wishes to evaluate a new spray that is claimed to reduce the loss due to damage by insects. To test the claim, the grower treats 12 of the trees in his orchard with the new spray and the remaining 15 trees with standard spray. The fruit yield in pounds from each tree is recorded. For this experimental design, identify the experimental units, the explanatory variable, and the response variable. Okay. A, B, C, or D. Let's see what you got. I got a B. I got a second B. Hopefully this is not from peer pressure, but rather because you believe this is the answer. I got an E. Well, that is interesting. That is very strange. I'm a little confused, I have to admit. As much as I like the letter E, I don't know what you mean by that. Unless you mean all of the above, possibly, or none of the above. J and K, now you're way out there. You skipped F, G, H, and I. I'm just kidding. Oh, I saw what you did there. So anyways, the answer is B. The answer is B. B is in Bozo the Clown. Let's think about it. One, we just talked about the experimental units. The experimental units are the things that you are testing, the individuals that you are applying your treatments to. What are the individuals here? The trees. This tree gets that. This tree gets that. The fruit, that's not the experimental units. That's what is coming out. We're measuring how many fruits there are. In fact, that's the response. That's what we're measuring. It says that. Where does it say that? The fruits in the fruit yield is recorded. This is the response. The only one that has fruit yield as a response is B. So let's just confirm that the middle one is correct. The spray type is the explanatory variable. It's the one that explains the response. This spray gives me this. This spray gives me that. So the answer is in fact B. So all of you who said B, you can rejoice. The rest of you, just you can be sad for a minute. I treat my explanatory like my cause and response like effect. So the only problem with that is that while there are times that you do have a cause and effect relationship, you don't always have a cause and effect relationship. So for example, I do this one in my class, but there's a very famous statistical fact that people who own more cars tend to live longer. I did this example in my class. You have more cars, you tend to live longer. Does that mean that if I want to live longer, I should go out and buy more cars? No, people who tend to live longer tend to have more money. People with more money tend to have better healthcare, better medicine, an easier lifestyle, etc. So there is a lurking variable behind the scenes to explain, yes, there it is, to explain the fact that this explains this response, but there's no cause and effect in that scenario. So while it's great to think of it that way, don't always think of it that way. Hopefully that made sense, because I have so many more examples up in here somewhere. All right, 110. The variable of interest in an experiment is called A, response, B, explanatory variable, C, factor, or D. I can't even finish reading the question. Gee. So the answer, or D, treatment. What is the variable of interest in? Yeah, basically at Alexis. So is the explanatory variable? Yes, I missed that. I'm sorry, I missed that. The explanatory variable is the independent variable that is correct, also called the predictor variable. Explanatory, predictor, independent, all of them. In this case, yes, the answer is B. I have 4 B's. So B, the explanatory variable, that is correct.
That was a mistake also on the packet. They
You-
put
You mean it's not? Oh, wait. Don't tell me what they put. The variable of interest, the variable of interest. Oh, no, it's A. What am I thinking? Boop, I'm a stupid person sometimes. The variable of interest in an experiment is called the response. It's what's right. Is that what they have? A?
Yeah, can you explain why?
The variable of interest is what you're measuring. It's what you care about. The explanatory variable, I change this. Let's see what happens when I change this. So you change the explanatory variable, but it's the thing that comes out that you care about, right? That's what I care about. I don't care about the explanatory variable because that's up to me. I'll do this, I'll do that, I'll do this, I'll change my sunlight, I'll change my whatever. But what we measure is the response. So the answer is A. I saw 4 B's there. I got excited. Everyone was correct, but unfortunately you all failed miserably. So I'll be sad for you, and let's just move on to the next one. So 111. Which of the following is not required for random sampling? A, B, C, or D? Again, my pep talk a minute ago, I had like right away a couple extra responses, but now I'm silent again. Let's get everyone to respond. Everyone. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have like 19 people here. Like 3 or 4 of you are responding. This is for you. Everyone respond. So which of the following is not required for random sampling? Let's take a look. 1, each population unit has an equal chance of being chosen. Well, that's simple random sample. Let's see if that's the one they're talking about. B, units are chosen independently of one another. Well, that's important. Yeah, we want that. And certainly independence is good. C, the sample must be perfectly representative of the population. Well, we usually want that. And D, some source of randomness, such as a table of random digits, must be used. Must be used? I don't know about must be used. Must be used? I mean, we certainly want randomness, but I don't know if they say such as a table, meaning it could be other things. Well, I'd have to go with A, to be honest. I'd have to go with A. I mean, we certainly want them independent of one another. That one is 100% we want. It says it must be perfectly representative of the population. I mean, if it's not perfect, is it really that horrible? This is a bad question. This is really a bad question. Because it has a word of must in it a few times. And the concept of robustness allows us to deviate from perfection. It can't be perfect. It marks C for this question. This is just a bad question overall. I don't like it at all. I mean, if it's not perfectly representative of the population, if it's off by 1, does that really mean that you can't use it? It's yeah, this is a this is a bad question, and just so you know, I went through the questions today, as I mentioned. There's nothing like this on it that has this kind of ambiguity, so I would just skip this one altogether. Let's not even worry about it. 112. An experimental design where the subjects are randomly assigned to the treatments is known as A, B, C, or D. A controlled design, completely randomized design, observational design, or a randomized block design. It is a, wow, everyone, almost everyone got this. B, 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 B. We got a D in there. So a randomized block design is not correct. The answer is B. But let's understand what the difference is between a completely randomized design and a randomized block design. If it's completely random, then everyone is randomly assigned to a treatment. But with a block design, is you actually separate the groups, the people, the sample into groups. Yeah, like suppose I'm doing an experiment where I want 50 people to try this and 50 to try that. Well, if I just pick people randomly, then yeah, I'll get 50 here, 50 there, great. But what if I end up with only men on this side, only women on this side? And that might give me weird results. So I want to make sure that each of the two has half men and half women. I'm going to block them. I'm going to put them in blocks and say men and women, 25 each, and then randomize those. So a block design is you put them into groups so that you get some structure to them, as opposed to completely randomized design where anyone could just be, you could end up anywhere you want. The difference between completely random and a block. Does that make sense? Great. So this is the end of this one. Why don't we jump ahead to the other one then? And we'll start, but can you go over the difference between a matched pair design and a two-pair t-test? So in both cases, you're going to use t. In a two-pair t-test, you have two samples. In a matched pair t-test, you have two samples. What's the difference? In a matched pair t-test, first of all, you're guaranteed to have the same sample size in both. If you don't, it can't be a matched pair. But why are you guaranteed to have the same size sample? Because every one of these is matched to one of those. Maybe it's the same person, left hand and right hand. Maybe it's the same couple, husband and wife. Maybe it's the same person before studying and after studying. But you're looking for a difference in an individual where the two observations are connected somehow. If you have that, then you want to use a matched pair, where what I care about is really the difference. I don't care about what the value is here and what the value is here. Did it go up? Did it go down? That's what I care about. What's the difference? Whereas for a two-paired t-test, I just have two samples and I'm just comparing them, but the two people in the samples got nothing to do with each other. Does that make sense?
Yeah, thank you.
Great. Okay. So here we have Math 140 SCI, but just be aware, Math 140 Business people, it covers the same thing. We call it Math 140 Business, but it's the same course. So review on normal variables. What is the probability that Z, the random variable Z, falls between negative 1.28 and positive 1.28? We have a D. We have a second D. We have 3 in a row. So this is, we have 4. So this is correct. The answer is D, and you can do it in a few ways. One way is, of course, taking out the calculator and having your calculator compute it for you. Not a bad idea, probably the fastest way. The other ways do require a little bit of knowledge. For example, the fact that if you go 1 deviation from the mean in either direction, what percentage of your data are you going to have if you go 1 standard deviation in both directions? should all know this. If you go one deviation in both directions, what do you get?
Do you mean like the 68, the empirical rule?
That's exactly what I mean. So if you go one deviation in either direction, you get 68% of the data. I am going here more than one deviation in either direction. Yeah, table is totally fine too, of course. If you go more than one deviation either direction, it's gonna be more than 68%. Here, it's not that much more than one deviation. It's 1.28. So it's either 79.94% or 89.97%. To be honest, just to be safe, I would do it because those are only off by 10%. So the table works fine. If I go to my calculator, negative 1.28, positive 1.28, 01, paste, I get 0.7994547331. So the answer is A. 2. What is the probability that Z is
Where do you go
greater?
on the calculator to get that?
Second, and then distribution, DISTR.
Oh, you just did normal CDF, right?
A normal CDF, yeah.
I got it. Thank you.
So what is the probability that Z is greater than negative 1.96? I got a D. I got a second D. I got 3 Ds. Oh, yeah. And that makes 4. So the answer is, in fact, oh, that's 5. So the answer is 0.975. First of all, of those 4 answers, 2 of them you should throw out immediately without a first thought, let alone a second thought. Which of those 2 should I toss right away? The 2 negatives. How could a probability be negative? Those are gone. And then we want to be greater than negative 1.96. Well, if you think of the normal curve, negative 1.96 on the left, there's lots greater than it. So it can't be 2.5%. It has to be 97.5%. 3, find the value of Z such that the probability being less than lowercase z, which is a specific value, equals 0.34. While you're thinking about that, Cynthia, what's up?
On the
Yeah.
calculator, for that one, we would do normal CDF, and then would the lower be negative 1.96 and then the upper 999?
Yeah,
Right.
negative 1.96 to 9999999, and that gives you the answer. And Belen, if you want to use your tables, I guess the other professor was big on tables. I was much bigger on calculators. But yeah, if you want to use tables, you look at that number on the table, it will always give you to the left. Well, it's because he's old and he didn't have calculators growing up. I can't think of any other reason. Oh crap, that's gonna be on YouTube. Oh, anyways. So if it's to the left, then yeah, you got to take that value and do 1 minus that, and you get to the right. The formula sheet for the final will be given, or do we have to print it V? Printed V. Why would you print it V? That doesn't make sense. But yes, it will be given. So have no fear. Okay. Anyways, number 3. Find the value of Z such that the probability being less than Z is equal to 0.34. What's it? Oh, we got a B right off the bat. Because you went to the tables. You probably have the table like open in front of you right now, because you are way quick. I'm gonna do it on my calculator, and I'm gonna get. Oh, I agree with you. It is B. Took me a lot longer than you. Maybe you should be teaching this course. How do we solve this using the table? Well, Belen, you want to explain, or do you want me to?
I could,
I cannot. Sorry, go ahead.
do you want me to share my table? I could explain using the table, like, so you
Yeah.
could visually see it.
Yeah, whoever's sharing right now, yeah, go ahead. That'd be wonderful.
Okay.
Button loves using tables.
There are forced to.
Well,
Yeah, I wish I did calculator.
button.
So what
Is
I did,
is he as cute as one? I don't think so. Okay, go ahead.
so what I did I tested out each like of the options and plugged them into the table and see which one matched up.
Yeah.
And so I plugged in negative 0.041. So right here it's negative 0.4. And then it's 1 right here. So I just go down. And I would get 0.3409. And that's
Great.
how.
Great. I actually would do it slightly different, which I think might be a little bit faster.
Okay, great.
Because the way you did it is you checked A, then you checked B and C and D until you hit the right one, correct?
Yeah.
But why not first go into the table and look for 0.34 and then say, oh, this is at negative 0.41.
Oh, see, that makes life easier. Because I
Right.
have to keep track so I don't lose the
Yeah.
spot.
Exactly. This way you go to the spot that you know the answer is going to be at, which is around there in the vicinity of that. And then just ask yourself, well, okay, what's the number? Negative 0.41. Hey, there's your answer.
Great. I will use that most likely for the test. Thank you.
No problem. Cynthia, what's up?
So on the calculator, I never used the tables, I always use calculator. But I'm kind of confused because how do I know when to put left and then when to put right? Because I've got a negative.
Well, do they want, in this particular problem, do they want what's to the left of that number or what's to the right of that number? Can we load up that, the test again? I forget which one of you is doing it. I'm sorry, but whoever you are, that's being very kind. Can you load it up, please? Because I don't know where it is. Did she leave?
The table or
No, the test,
worksheet?
the worksheet.
Okay.
The one that we were doing. You there? Hello. Okay. Anyone else have it? I can try to find it.
I have it if you, oh, never mind. She isn't.
Is back? No, it's not back.
Yeah.
I got kicked out. You got kicked out?
Yeah, I got kicked out really fast.
Who kicked you out?
Now I'm on my hotspot.
I'm gonna have a, oh, never mind the hotspot. Okay, so you were the one who was sharing the test?
That was me here.
All right, well, let's get back to it, shall we?
Sorry about that.
I will forgive you, but I think you have to get forgiveness from everyone here.
Everyone here.
All right, what number were we on? Oh, right there. Okay, so look, Cynthia, look at it. It says the probability being less than Z, correct?
Yeah.
That's to the left, right? Less than a number, so it's gonna be to the left. If it was greater, then it would be to the right.
Okay, so the answer was negative 0.41.
Negative 0.41.
Thank you.
And it has to be negative, by the way. Oh my God, I didn't even need to do any of that. There's a much faster way. Look at the four answers. Only one of them is negative, and we want a probability of being less than a number to be less than 50%. If you are less than 50%, then you know that you're going to be to the left of the center, and the center is at 0. So it has to be a negative. There's only one negative there. Of course, I didn't even see that till just now. So it's probably not the first thing you would notice, but it's just all these little things that's, the better you get at this, the more you can notice these little tricks and whatnot that save you time, which can be a huge thing in the long run. So number 4, if the Z value for a given value X of the random variable capital X is Z equals 1.96, and the distribution of X is normally distributed with a mean of 60 and a standard deviation of 6, to what X value does this Z value correspond? Lots of words there. But come on, Belen, you're the master of Z-scores, you said, right? I love Z-scores. Oh no, she said I like Z-scores. And I love,
It's the one I enjoy the most, but I actually got stuck on this one.
I see.
Probably because of wording.
Yeah, the wording's a little funky. But at the end of the day, let's ignore the wording and just look at the values that we have. We have Z, we have the mean, we have the standard deviation, and we're asked to find the X. What formula do we have that connects all four of those? Because we only have one.
Would it be the z-score formula?
It'll be the Z-score formula, right? The Z-score formula, and says that Z is equal to X minus mu all over sigma. And we know three of those four, and we're asked to find the fourth. So assuming that you can do some algebra and maneuver it, you should get the right answer. So I have a C out there. What else we got?
I have a really quick question. Is the z-score also like considered as a z-test statistic, or is that a different formula? Like, are they the same?
They're the same and they're not the same. In all of your formulas where you are computing a z-test statistic or even a t-test statistic, every one of them is data minus mean divided by standard deviation. Every one of them. It's just standard deviation gets a little tough when it's a sample. Sometimes you have P1 and N and or P2 and you have this and that, but form-wise, yes, they're all the same. So yes, in this case, this is a diluted form of that where you can just plug everything in and yes, you should get C 71.76. What I did is I said 1.96, that's kind of like 2. So 2 times 6 is 12 and then add 60, 72. Oh, 72 is not there. Well, it was a little less than 2. It was 1.96. So it's going to be a little less than 72, 71.76. Bella, in this case, that's what we're solving for. We're solving for X. We have everything else. Yes, no, maybe so.
I still don't understand. Well, I understand like to find the X, but I'm having trouble understanding like the answer, like
What's
how you obtained it.
so do you agree with the formula that I have there currently?
Yes.
And if I replace Z with 1.96 and I replace mu with 60 and I replace sigma with 6, you understand this formula here, correct?
Yes, I understand.
Okay, so how do I manipulate that formula to get X by itself?
Divide the 60 by the 6.
No. You can't divide because the division symbol is underneath both of these. So you can't just kind of pick and choose and say, I want to do this one. And what about this one? They're both going to get it. So here, what you want to do is you want to cross multiply. You want to multiply those two. Or multiply both sides by 6. It has the same effect. If you multiply by 6, those cancel. And then you have 6 times 1.96, which is about 12. And then you add 60 to both sides, about 72.
Okay, I get it. Thank you.
Make sense? Okay. All right, number 5. What type of sampling is being employed if the country is divided into economic classes and a sample is chosen from each class to be surveyed? A, B, C, or D? So this is C. It is stratified sampling. It's kind of like a block design, really, although we're not designing an experiment, we're just doing a sample. But it's really the same in the sense that we break up the population into groups, and then we pick some from each group. Stratified sampling. 6. Which of the following is an example of non-random sampling? Which of those is not random? So, anyone notice a little typo in this problem? Anyone see a typo?
Wouldn't it be voluntary response?
Well, is that D?
Oh,
Oh,
There are two Ds here, in case any of you have noticed or not noticed, apparently. So the answer should be C. I mean, voluntary sampling is in the place of what would normally be C. And not the true D. Will the true Ds please stand up? No. So the answer is C, voluntary sampling. I hope everyone who said D meant that. We all met C, really? You met him? What was his name? Oh wait, his name was C. That doesn't make any sense. That was a bad joke. Oh, you can't win them all. So C is crying right now. Yeah, that's right. Get back in the corner. Men's? Okay, well, your spelling is not good today. You speak English good. Anyways, number 7. Oh my God. Well, I don't even know what that word was supposed to be. 7. Following a dramatic drop of 500 points in the Dow Jones Industrial Average in September 1998, a poll conducted for the Associated Press found that 92% of those polls said that year, no, I lied, said that a year from now, their family financial situation will be as good as it is today or better. Yay. What is the number 92%? A, B, C, or D? We got a couple C's. We got an A. We got a couple A's. I sense a fight brewing. Oh, 1, 2, 3, 4, 1, 2, 3, 4. Oh, the A's win it. Oh my God, look at that come from behind win victory. Down 4-0. They came back and won in 9, 5-4. Yes, the answer is a statistic because it came from a sample. 92% came from a sample. It was a poll. It wasn't everyone. Anytime you have a number, a numerical quantity that comes from the sample, it is a statistic. Parameters come only from the population.
a poll can also be like referred to a sample.
I'm sorry. A poll is a way of getting a sample,
Oh,
right? Any way that you can remember, we have a sampling design, which is your method for getting a sample. A poll, I betrayed my intuition. Belen, your intuition is really angry with you right now. I can tell. They feel that you don't trust them anymore. And they and I would like it back in your confidence. So you have some work to do. Question 8. If a statistic used to estimate a parameter is such, the mean of its sampling distribution is not equal to the true value of the parameter being estimated, the statistic is said to be A, B, C, or D. We got a couple B's out there. Waiting for all the other members of this group to chime in. Wow. Unanimous and correct. The answer is biased. Whenever the expected value of your statistic does not match the true value of the parameter, we have a biased sample. Much like the average number of people or the average percentage of people who prefer basketball as their favorite sport. If I go to a Lakers game and I poll people, it will be biased because the value of my statistic is not going to match the true value. It's a biased sample. Question 9 and 10. A study of college freshmen study habits found that the time in hours that college freshmen use to study each week is approximately normally distributed with a mean of 7 hours and a standard deviation of 5 hours. What is the probability that a randomly chosen freshman studies more than twice the average number of hours? That was going to the table. I'm going to the calculator. Let's see who wins. I put it in wrong. That's better. Okay. Oh, wow. So many already had the answer already, or a answer. So she said, Alexa said, we use a T statistic, right? So do we know the true standard deviation? Yes. We are told that it's normal with a mean of 7 and a standard deviation of 5. Because we're given that information, we use Z. We use T when we don't know the standard deviation. In this case, we do somehow. Doesn't tell us how, but we know somehow.
I always get confused, like the difference between Z and T in like word problems. What are like some keywords?
Well, there's really only one key word that you need. And that's if you know sigma or you don't know sigma.
Mhm.
If you know the true standard deviation, use Z. If you don't, use T. Everything else is window dressing. You don't need it. All you need to know is, do we know sigma or do we not know sigma? In this case, we do. We don't need a Z. Oh, you want to use a Z score? Well, that's the question here. If you use your calculator, you don't need a Z score, by the way. If you use your calculator, you go right to the answer. But if you don't have a calculator and you want to use a table, then yes, you will need a Z score. So to get a Z score, if you go to your Z score formula, we need 3 things. We need X, we need mu, and we need sigma. Do we know mu in this case? Do we know the mean? The 7. Do we know sigma in this case? Five. Do we know X in this case? Actually, we do. Yes, we do. It's not 7. It's not 2. $14 is correct. 14. Twice the average. What is the probability that a randomly chosen freshman studies more than twice the average? If the average is 7, twice the average is 14, and that's our X. We want to know if it's more than X. So 14 minus 7 over 5 is 1.4. So we want to see if it's more than 1.4. The answer is, in fact, A. Alexis, what up?
Sorry, so the formula we use is Z equals X minus mu divided by sigma.
Yes, but not in a laughing way. We want to do it in a very serious way.
In a serious way, got it.
Serious way. Why are you laughing? What's so funny?
Your energy is just so amazing. This is just such a mind trip. I'm messaging students in my class. We are so jealous that we didn't get you, Professor. This is insane.
Aha, you're making me blush. Like, that was crazy. You win today. So but I do appreciate that. Thank you very much. It's very sweet of you. Really, I do appreciate it. Alexis, what's up?
Okay, so would the sampling standard deviation
Thank you. Yes.
be considered a t-test, right? Since it's not the actual standard deviation?
Oh, no, we have sigma. They told us it's 5.
Oh, okay. So, but like the samplings. Oh, I see. Oh, wait, I think I'm confused.
Good, Bellin, my professor made me lose all my hair, so it's all good. I prefer gray over nothing. Trust me. Trust me. But yeah, sigma here is 5. So we know sigma. So the answer, no, the answer is not B. Who said B? You've been crying these last 2 days. Oh no, math should make you cry. Math should make you dance in the rain. Math should make you just love life. Or kill yourself, one or the other. Now I'm going to be watching. Yeah, okay. Good luck finishing all of them by the test. There's like 40 of them or something like that. Oh, okay. All right, but I do appreciate, guys. Thank you so much. Please like and subscribe so I can get like, money and stuff. That'll be awesome. Okay, so where are we at right now? Anyway, so did we all get A? Yes, good. Oh, and by the way, for those of you who do like me, and I do appreciate that, and I'm not saying this is going to happen. I'm going to assume you're all going to do amazing, but if any of you, for any horrible reason, do have to retake a Math 140, I am teaching it next semester as well. Just throwing that out there. Anyways, so do we all get A? I got B. You got B. How the hell you get B?
Well, like once I did the C, like the equation and everything, I got 1.4, right?
You got 1.4, yeah. That's for your, that's your X. That's not your Z.
Oh, crap.
You got to convert, you got to get Z, right? You get your
Well,
X.
I went to the table and I got 0.912, 9192.
Wait, but you went to the table for what number? For 1.4?
Yeah.
But that's, you can't do that. You have to get to Z.
Oh,
Yeah, see, the table
okay.
doesn't give a shit about X. The table cares about Z. So when you have your X and your X is 14, you got to get your Z score and then go to the table. Or you can join the 21st century and get yourself a calculator. Because the calculator, we don't need no tables, right? This isn't Button's world. This is my world. Okay, you get your calculator.
Which one we use on the calculator? Like I got the Z-score, which is like 1.4 after doing all that. So what do we do after that?
You go to normal CDF. Yeah, you tell them, Cynthia. You tell them.
You just go to normal CDF. Wait, you press second, distribute or reverse, and then you go to normal CDF, which is the second option. And then you put in your lower, which is 14, and then your upper, just put a bunch of 9s, just put like 5. And then you put your 7, and then 5 as your standard deviation. 7 is the population mean. And then you press and paste, and then it gives you 0.08.
Thank you.
Wait, Professor, sorry, I'm a little stuck. I did the formula, which is, and then I got 1.4. What do I do after?
So now, are you doing a table or are you doing your calculator?
Table,
Well,
unfortunately.
first of all, wait a second. You said you use a formula to get 1.4, right? Okay. Sorry. So, right. I think I might have heard 1.4 and thought I heard 14, right? So once you have 1.4, I'm sorry. Bellin, I think I might have misheard you before because in my head I was thinking 14. 14 is X, 1.4 is Z. So now that you have your Z, we want to know the probability of being more than that, correct? So either on my calculator or the table, I'm going to go to 1.4, and then my table will give me to the left, not to the right. We want to be to the right. So if the table gives me 0.9192, 1 minus that is 0.0808.
Got it.
Okay, so I saw what I did. So I didn't realize it said more than, and so since I had to use the table, I subtracted 1 by 1.4. Well, not 1.4, the probability on the on the table, which
Right.
was 0.9192, and I subtracted by 1, and then that one gave me 0.0808.
And that's the answer.
Oh my God.
I know. I've been called worse. All right, question 10. What is the probability that the average number of hours spent studying by an SRS of, I hate T table. I'm not sure what that means. But what is the probability that the average number of hours spent studying by an SRS of 25 freshmen is greater than 8.4 hours? This was a little tougher. We got two things we got to do here. What do we got to do? We got to find Z, right? Just like before, we got to find Z. How do I find Z in this case? Alexis, your hand's still up. Did I answer you or is that from before?
Yeah, sorry about that.
I forgive you. So we still have the same formula, Z equals X minus mu over sigma. That is still holds. But in this case, there's a complication. What is the complication in this case?
We don't have sigma.
We don't have sigma. We had the sigma before, it was 5. What changed?
Would it be the X?
Well, X changed also. 8 is, no, it's an SRS. We love SRSs. Whoa, hold on. Don't knock SRSs. SRSs are like the best thing on the planet. Well, not as good as a good steak, but like the second best thing. SRSs are amazing. So I love SRSs. No, X is 8.4. We have X. X is 8.4. They gave us that. Do we have mu?
It's 7.
8.4. Oh,
U is how much? 7. It's still 7. That hasn't changed. Do we have sigma? What's sigma?
Is it 5 or has it changed?
It's changed.
Changed now.
It's changed. And the question is, why has it changed? I mean, this is still those 3 lines in the top.
So we do 5 over radical n, and we use 25 for the n.
Yeah.
Got it.
Yeah.
So 5 over 5, basically.
Yep. Which becomes what?
1.
Yeah.
So z becomes 1.4.
Z becomes 1.4. Yeah. Oh, 1 point. Yeah. Isn't the same thing we had last time? Crazy. And we already have that.
So same answer.
Oh my God, look at that. OMFG. Same answer.
So where do we plug in 20? Oh, that. Oh, okay. Sorry.
This should be, yeah, the sigma. This is what I was saying earlier. Someone asked about Z scores, Z statistics and whatnot. And I went on this whole long tangent about when you do your test statistic, your standard deviation is not always going to be sigma. It'll be more complicated because we have a sample. When you have a sample, you take the original sigma and you make it smaller. We want to make it smaller because having a larger sample means we kind of hone in on the true value. No, it's still a Z statistic. It's still Z. It's just a smaller sigma because it's a larger sample size. Think about it. Suppose I go to the mall or somewhere and I start my stopwatch at a random time and I say, when my stopwatch hits 100 seconds, the next person who rounds the bend, I'm going to see how tall they are. And sure enough, a few minutes later, somebody comes around and the person's 6'3". Okay, 6'3" is kind of tall, right? Not exactly the most common height, but certainly when you walk around the world, you see people who are 6'3". It's not like it's like, oh my God, someone's 6'3", that's crazy. But if I averaged heights of 25 random people and I got 6.3 or 6'3", now this is crazy because for the average of 25 people to be 6'3", they pretty much all have to be tall. And what are the odds of that happening? That 25 people are all going to be tall that are chosen randomly. So when the sample size goes up, observations that in and of themselves might not be rare become rare because my standard deviation gets smaller. So I have a tighter range of reasonable outcomes, and ones that are further apart now become unreasonable. And then the question is, mathematically, how do I do that? And the answer is right here. The sigma for a sample is the original one divided by the square root of the sample size. And every type of scenario, whether it's proportions or T or Z or one sample or 2 samples, all the formulas may be different, but they all have the same thing in common, that if the sample size goes up, sigma goes down. Does that make sense? Hopefully it did. And I wasn't just talking to a wall. I can never tell. But I'm hoping. Oh, I got a thumbs up. I got a thumbs up. I'll take it. All right, let's keep going. 11. The sample statistic X bar is an estimator of what? A, B, C, or D? Oh, we got a triple A. Oh, like my card being broken down. 4 A's. The answer is yes. The answer is mu. X bar estimates mu. The sample mean estimates the population mean. 12. The sampling distribution of X bar shows how blank varies from blank. Oh, I like that question. Oh, Alexis, C with a question mark. You gotta be confident. You gotta say C, but it's not C. C is wrong. My brain cells left the chat. Yeah, I hear that. It's 2 hours though. It's a long time. I'm only here because they're paying me. Otherwise, I wouldn't even be here. But it's tiring. The answer is, in fact, A. The sampling distribution of, yeah, seriously, right? The sampling distribution of any random variable shows how that variable varies from sample to sample. It can't be population to population. There's only one population. How do you vary from like the average height of every American? Okay, every American, that's my population. You can't vary from that to itself. That doesn't make any sense. But you can vary sample to sample, right? But it's not mu because, Bellin, mu is the true value. The true value doesn't vary. It is what it is. We don't know what it is, which is why we take a sample to estimate it. If I go out there and I measure 10 people's heights, I will get a value. If I measure another 10 people's heights, I'll get a different value because it varies from sample to sample. X bar, my average, my estimator, is varying from sample to sample. Does that make sense? Good. Good. Is good. 13. It is known that the mean GPA of all undergraduate students at a large college is 2.58. Any random sample of 200 students. Sample mean, we got grammar issues again, but anyway, sample mean is 3.01. The difference between 2.58 and 3.01 is that means it's got a name. What do we got here? I have to read it again. I wasn't paying attention. Okay. Okay. What do we got? Uh-oh. Either everyone became a mime all of a sudden, or no one's paying attention. What's going on here? Standard error we have. Oh, we have a couple A's. Trying, that's all I can ask for, and apostrophes. B, this is weird. This is weird. What is weird? Silence is weird. So I have a few A's, these questions. Yeah. I mean, I'm not really the biggest fan of definition questions. I'm more of a fan of like doing math questions and numbers, because you can do the math, and if the answer that you get is there, you're like, hey, it's there. This is probably right. But with words, it's like you never really know if it is because nothing to actually do. The wordy ones. Yeah, but at the end of the day, definitions are important to know. And the answer to this one is the sampling error. The answer is B. The sampling error. The only reason it's an error is because I took a sample. Right? My sample is this. The true value is that. My error came from my sample. So it's a sampling error. Right? I hope so. 14. The sampling distribution of a statistic is A, B, C, or D. Oh no, another wordy one. Two A's and a B. And where's the other like 19 people that are here? Come on, speak up. Manda, where are you? You're not saying a word. What's going on? Okay, we got B, 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 4B, 5 B's, and 3 A's. Thinking. I'll give you another minute then. I'll give you another minute. Wait, which number? Oh, where'd it go? Uh-oh. Person in charge, scroll back up. We lost it. There it is, 14. B, bunch of B's, bunch of A's. Ooh, we got a C in there as well. Another A. All right, Mando, I'm waiting on you. The whole world is waiting on you. Can't be thinking that much. Don't got that many brain cells. You got this. You got this. Come on, Mando. It's a cool name, Mando. I wish I had a name, Mando. It's really cool. The answer is B. You did get this. That is the correct answer. The probability distribution of the statistic. Awesome. Let's see why. Well, first of all, that's too late. I'm stuck. Everyone calls me by my real name. If I changed it, it would be weird. So it's not always normally distributed. In fact, it's only normally distributed if the sample size is large. It's called the central limit theorem. Otherwise, it can be very, very skewed, but it doesn't have to be skewed. So it's not always normally distributed. It's not always a skewed distribution. It could be. And it's certainly not D. D is the worst answer because there is no probability distribution for the population. Well, actually, I guess there could be. But because it's a sampling distribution of a statistic, it is the probability distribution of the statistic. It is the thing that you're measuring. The thing that you're measuring has multiple possibilities. And that is its probability distribution. So the answer was B. What was question 13 again? You got 3 point something. The true value was 4 point. You got 2 point. Shit, what is it? You got 3.01. The true value is 2.58. What's the difference between them called? It's called the sampling error. Number 15. According to the central limit theorem, the CLT, not to be confused with the BLT, which is much better. For random samples selected from a non-normal distribution, the sampling distribution of the sample mean is A, B, C, or D. Mando, think less this time. You got this. Everyone's saying A. Well, who am I to argue with that? Let's take a look. B is wrong, C is wrong, D is wrong, A is right. Approximately normal when the sample size n is large, that is correct. That is in fact what it says. There's a great applet that I showed my students, the central limit theorem applet. If you can go on Google or something, look it up later. Central limit theorem applet. And the link, it's like one of the first few links. There's like a bunch of numbers. You can tell it's the right one by a bunch of numbers. And you can make distributions of different sizes. Yeah, we use Crunch It. I actually like Crunch It. We use it a lot more in the first half of the year. And then as we got to confidence intervals and whatnot, I kind of shifted to more calculator stuff. Why is it A? Well, that is what here, you know what? Yeah, Crunch It's nice. Go ahead and button. Do you believe everything button says? All right, go ahead and unshare for a second. I'm going to share something on my ends, which I think is a good thing. My students have already seen this, but it's never a bad idea for everyone to see it. So let me share my screen. Open system. It's not letting me share my screen. What the? What? Why is it not letting me share my screen? It's giving me technical difficulties. I'm sorry, I can't share my screen. So go back and share the test, please. But the rest of you, please load up central limit theorem applet. And the link is actually the first one. It says
I
like,
can try it if you want really quickly.
I'm sorry?
I can try it.
Yeah, if you don't mind, that'll be wonderful. Thank you. Central limit theorem applet. Because this is really a powerful observation. You can really see the central limit theorem in action very well. It's the first one. So let's pick one of the 8 distributions. We'll pick one that's not normal looking. Let's pick number 3. So click 3 and then click draw a sample. All right, so if we draw a sample from this, we see that we get lots of values on the left, we get some values on the right, not too many in the middle. Now, if we increase our sample size to 2, and then INC, right, yeah, right above, no, there, oh, there, button to the right, there it is. And we draw again, then the distribution shape changes. If we go to 3, it changes again. If we go to 4, it keeps changing. What happens if we go to like 7 or 8? Let's jump ahead a little bit. What do you notice happens as the sample size gets larger? Go to 10, let's see what happens. So even if the underlying distribution comes from a non-normal distribution, not only does the standard deviation get smaller, which yes, both of those are correct. That's the whole idea. It gets more normal and the deviation gets smaller. Go to a sample size of 20. It'll still look normal, but you're going to see it's going to be a lot thinner. This is exactly what the central limit theorem says. No matter what distribution we start with, if the sample size gets large enough, it starts to look normal. And as the n gets even larger, it gets really, really tighter. So we hone on the true value. This is why we take big samples. Otherwise, why? Why not just take one? Saves us time, saves us money, saves us energy. Because the bigger your sample, the tighter your distribution, which means you hone in on the true value a lot better. So that's the answer to why it's A. All right, so let's go back to the test thing. Oh, describe your goals. My goals are to do well on this test. All right, what do we have here? 16. Since the sample size is, what's wow? Uh-oh, was it me? Thank you, oh my God. 16, since the sample size is always smaller than the population size, therefore the sample mean must A, B, C, or D. We have an A. Do we have anything else? We have 2 A's. We have 3 A's. We got a B. We got a C. And finally, we have the correct answer, D. D for doggone it. How come it's not C? It's a great question. Are you telling me that every sample average is going to be equal to the true average? Some will be smaller, some will be bigger. She said true twice. That means not only did she agree with me, but she agreed with herself as well. So the answer is D, none of the above. 17. To determine the mean amount of cereal dispensed by a filling machine, a random sample of 32 boxes will be selected and their contents weighed. The sample mean X bar will be used to estimate the mean amount of cereal. That makes sense. Why not? Determine the probability that the estimate will be off by less than 0.2 ounces. And assume that the standard deviation of the fills is 0.8 ounces. So they're giving me sigma here. That's nice. Can someone link the prof YouTube channel where he posts the recordings? Anthony Jackson, where did you come from? I don't have you on my list. Anthony Jackson. I feel like there was a president with that name. Anthony Jackson. Anthony Jackson. Maybe not. I don't know. Oh, Andrew Jackson. Yeah, that sounds better. That makes a lot more sense. That's right, Andrew. Good old Andrew. All right. Anyways, to determine the amount, oh, I lost track. Where am I? 17. So we have a random sample of 32 boxes. The sample mean will be used, and we want this to be off by less than 0.2 ounces. And we assume that the standard deviation of the fills is 0.8 ounces. What is the probability? So someone said Z statistic, right? Sure, you can do it that way. There's actually multiple ways, but Z statistic is certainly, well, Z statistic or Z score?
Score, no. Statistic.
I was gonna say score, but then you change it and it's wrong. So no, it is Z score. Yeah. Is that a shocked face? I can do a pretty good shocked face, I think. So it is Z score. In other words, we want to know the probability that it's going to be between what two values? Actually, we don't have the true value, do we? Oh, this question is actually not straightforward. This question is actually not straightforward. But here's how I would do it. We're looking, this shouldn't be here. This is a little too complicated, but we're looking for the probability that the difference between my value or my average value and the true unknown value is less than 0.2. This is what we're looking for, right? The probability that the difference between my average X bar and the true average mu, that the estimate will be off by less than 0.2, which is the same thing as the probability. If you remember your algebra, the negative 0.2 is less than X bar minus mu, which is less than 0.2, which is the same thing as the probability that mu minus 0.2 is less than X bar, which is less than mu plus 0.2. And this is the same thing as the probability if I subtract the mean and divide by the standard deviation, the negative 0.2 over 0.8 is less than Z, which is less than positive 0.2 over 0.8. And you'll see the miracle that I actually don't even need to know mu to calculate this. It is not simple. This was, I would not have asked this personally, Anna. I would not have put this here. But yeah, I don't know if whoever wrote this was expecting you to do that, or if they possibly taught you a trick or something. But the answer ends up being B.
Is there another formula we can use for this, professor, or is it that one, that specific way?
Yeah, the answer key is wrong. Oh, wait, no, the answer key is not wrong. I didn't take into account the sample size. I didn't take into account the sample size. Whoops, sorry. When I divide by 0.8, I ignored the square root of 32 underneath. Whoops, that would have been bad. But can I think of another way of doing it? So first, sorry about that. That was my bad. First, let me make sure that that is there. Negative 0.2 divided by 0.8 divided by the square root of, whoops, divided by the square root of, square root of 32, negative 0.044, negative 0.044 to positive 0.044. That gives me 0.0. Oh, yeah, okay. Times the square root of 32, negative 0.1414. Negative 0.1414, negative 1.414 to positive 1.414. Sorry, I'm just talking to myself right now. Yeah, okay, yeah, it is D. But back to your original question, is there an easier way? There's got to be an easier way that I'm just not seeing, because I can't imagine they would want you to do it this way. But I'm just not seeing it. I'm not seeing it. You won't see this on the exam. There was no question like this. But what did I plug in? I don't. There's got to be an easier way. I'm just not seeing it. I'm just not seeing it. But this is how I would derive the answer. I'm just not seeing it. Sorry.
Does it make sense to do, oh wait, no, because it gives you a random sample of 32 boxes, so there's no way to do the z equals x minus mu divided by sigma, right?
Well, we don't have x, right? It's asking us, and we don't even have mu. So the way I did it is the way I see it. There's got to be an easier way. I'm just not seeing it. I'm just not seeing it. I put in, how do I get those numbers back? Is it too late? Undo. There they are. So I put in this number here, negative 0.2 over 0.8 over root 32 to positive, same number. And I did the math. I'll think about it. You know, we'll start here tomorrow, or yeah, my next lesson is tomorrow, right? Tomorrow at 2 o'clock. So I'll ruminate over it tonight, and I'll try to think of an easier way to approach it, even though I'm not seeing one right now. Well, let's finish the last two here, and then before we stop. So 18. As a sample size increases, I know it's like, well, it's time flies when you're having fun. What can I say? As the sample size increases, oh, I can't leave yet. They're paying me to say till the end. Sorry. Okay, so as the sample size increases, the A, B, C, or D. As the sample size increases, the what? A, B, C, or D? Oh. Got a few D's. Okay. Oh, we got a C. We got a few C's. Got a bunch of C's. 3 on 3. Who's going to break the tie? 3 C's, 3 D's. Someone break it. Just don't say A or B. We got a D. And the answer is D. D is correct. No, don't answer the wrong answer after I say what the correct answer is. Jeez, that's like, you know, multiple choice 101. So let's think about it. First, A and B. Nothing is going to change in the population no matter what you do. So it can't be the population mean does anything. That's the true value. So as the sample size increased, we just saw the applet a few minutes ago. What happened? What happened to it as the sample size increased? It got tighter, right? It decreases. It gets smaller. D. The answer is D. And number 19. A survey of 250 lobster fishermen. Is that a thing? I guess so. Found that they catch an average of 32 pounds of lobster per day with a standard deviation of 4 pounds. If a random sample of 30 lobster fishermen is selected, what is the probability that their average catch is less than 31.5 pounds? Let's do this one to end it up. Oh, man, I got a headache. All right, we got some math to do here. We can't just do this one in our heads. This one has some math. So it was D for 18. Yes, it was D for 18. So I can't tell if any of those numbers are for this one. I think that was for the last one. So still waiting on 19. We got a couple A's. Oh, I better do it too. So normal CDF. Less than 31.5. And 250. Main was 32. And we want less than 31.5, right? Okay. 31.5. Okay. All right, I got my answer. Oh, my answer is not there. What did I do wrong? Uh-oh. Hold on, Alexis. 1 second. See what I'm doing wrong here. Mu is oh, whoops, no wonder. No wonder. Okay, there we go. All right, I have the answer, and the answer is in fact A, so that's good. Everyone, mostly everyone. Bellin, what do you do? 0.7517, where'd that come from? You there? No? Okay, Alexis, what's your question? What's up?
Do we convert the standard deviation of 4 pounds? Do we do 4 divided by the square root of 250, or is that?
No, but we do 4 divided by the square root of 30.
Interesting.
Because I know. Because our sample size for our data set was 30. We might have asked 250, but we only have data from 30 of them. Let me rephrase that because that makes no sense based on what I just read. We have 250, we have their average, we have their standard deviation, 250, 32, and 4. Now, we take a sample of size 30 from that population. So the population here is all 250, but the sample is just a 30 of them. So the N is 30 for this problem. Does that make sense? Yes, no, maybe so.
Yeah, so what do we do after we get the 7.73029?
What is that number that you just gave me? Is that 4 divided by the square root of 30?
Yeah.
So that is your sigma. So then you can use your z-score and do 31.5. This is Bell, and this is your answer as well. 31.5 minus 32 divided by 0.73, and that's your z-score. And then once you have your z-score, go to your table. Cynthia, question?
So on the calculator, I did normal CDF, but I put as the lower it's 999, and then the upper is 31.5.
Yes. Negative.
do-
Negative.
Oh,
Not
okay. Oh yeah, okay.
positive.
Okay, that's why I wasn't getting my answer. Because I didn't put negative on
Yeah,
the
yeah.
9.
If you go the wrong way, then it makes no sense.
Okay, thank you.
You're welcome. All right, everyone. Any last questions before I go? I'm not sure if I can make it tomorrow to your session, which I would really like to. Thank you. Is it possible you can screen record and I can watch it on your YouTube channel? Yes, of course. More than happy to. I will do it tomorrow as well for our personal class. You are welcome. And for our personal class, what the hell is that?
I was wondering, the attendance, is that count towards extra credit or
No, I'm only taking attendance here because the math department asked me to.
no, in our class, like in our math
Oh,
147?
yeah. It's only extra credit. Doesn't count against you.
Okay.
Aliyah, tomorrow, let's do confidence intervals and hypothesis testing. We'll focus on that tomorrow. How's that? Yes, like a snake. Yes. Any other questions?
For number 19, what equation do we use?
The same one, z equals x minus mu over sigma. Same equation. For any normal problem is probably going to be that in one way, shape, or form. Z equals x minus mu over sigma. All right. All right, everyone. I hope you learned something. I hope you got something out of it.
Wait, Professor, I had a quick question about the final. I know that there's no notes, but you said we can take a formula sheet. Well, do we have to bring that?
No, I didn't say that. No, we will provide a formula sheet. You're welcome, everyone. You're welcome. We will provide formula sheets. No formula sheets are allowed.
Oh, okay. I see.
Yeah,
right,
it's not my
thank you.
call. It's, people in charge. Alexis, what up?
Sorry, a quick question. So, since I just found you and I don't have enough time to look at your other videos, if I do the review packet, if I watch that YouTube video and I do this and I come tomorrow, do you think that that's still good prep for the exam?
Oh, yeah. I saw the exam.
So it's similar to this review packet, or will I cry again? What do you think?
Well, I think we all need a good cry sometimes. But I would say if you understand everything I did today, you're welcome. And you understand everything that I did yesterday and everything that I do tomorrow, you'll be in a pretty good spot to if you remember it, to do fairly well.
Okay, thank you so much.
You're welcome so little. Oh, so cool. Anyways, everyone, I gotta run. So good luck out there in the world and stuff. Mando, you the man. I hope you didn't die in, or you don't die in wherever you're at right now. I know you're in the hospital or something, but live. The rest of you go. I gotta record this. I gotta leave. Bye, everyone. Okay. All right.